This is the last two applications for using the Pythagorean theorem to find missing side lengths. So it takes a little more thinking, but we're going to use the same process. So if I know I'm going to use Pythagorean theorem to solve, then I'm going to start by writing my formula. A squared plus b squared equals c squared. The trick is this time, if I'm looking at this pyramid here, then I'm going to have to think a little more critically to figure out my A, B, and C values. So this is the entrance to the Louvre Museum in Paris, France, and it's a square pyramid. So obviously it has triangular faces here on the outside, but it's a square pyramid because of the square base. So if it's a square base and this side length is labeled 35.4 meters, we know that every side is 35.4 meters on this square base. They've also given us this slant height here. And they've told us that that is 27.9 meters. So we have that value. We also know this length, but what we need is to find the height of the pyramid. So if I'm looking for the height of the pyramid, then I need to be thinking about dropping a line down from the vertex of the pyramid up here, the very highest part. I drop, almost think of a string that drops down the center of this square, and that's going to tell us the height of this pyramid. So if I drop a string straight down into the center of this square base, that's going to form a right angle with the ground. So now you can see where we are going to get this right triangle. So the height is what I'm trying to find here, this value. So my C value is going to be the one that is across from my right angle. So this is my hypotenuse that we've highlighted in red, the slant height, this 27.9, that's my C. What I'm trying to find is the height of the whole pyramid. That's going to be my B, and this distance here is going to be my A value. So we need to think about this A value here. If this is going from the edge of the square to the center of the square, then this distance ought to be half as long as the side of the square, right? It's going from the edge of the square to the center, so halfway across. So it's going to be half of 35.4, which half of 35, half of 35.4 is going to be 17.7. So this A value is going to be 17.7. So let's substitute in now. I know my A value, 17.7 squared. I don't know my B value, that's the height of the pyramid I'm trying to find, but I do know the C value, which is 27.9 squared. So now we're going to simplify. So we're definitely going to want to use our calculators for this because I, for one, do not know 17.7 squared off the top of my head. So I'm going to do 17.7 times 17.7, and I'm going to write down exactly what I get, which is 313 and 29 hundredths. And then I'm going to do 27 and 9/10 squared and write down exactly what I get, which is 778 and 41 hundredths. Now to get B by itself, I'm going to simplify by subtracting from both sides. Let me change, there we go. So when I subtract, I get a difference of 465.12. Now my last step to get B all by itself and remove this exponent, I'm going to take the square root. That's going to undo my exponent of 2. If I take the square root of the left side, I have to take the square root of the right side. My equation balance. And I get a square root of 21.5666409, and it keeps going. But I know that I need to round to the nearest tenth. So 21.56 is going to round to 21.6. So the height of this pyramid is 21.6 meters. All right, we're going to use that same idea for this last one here. To the nearest tenth, what is the height of the square pyramid? So again, I know a side length and I know the slant height, but I don't yet know the height of the pyramid. So I'm going to drop a line down here, and that's going to give me my A, my B, and my C. So now I can start by writing my formula, a squared plus b squared equals c squared, and substituting the values that I know. I don't know a lot. I know I'm trying to find my b value, so that's going to remain the same. A, again, is going to be from the edge of the square to the center of the square. In other words, halfway across the square. So this a value has to be half of 28.8. Because 28.8 is the whole distance across, and I'm stopping right in the middle. So half of 28.8 is 14.4. So I'm going to put 14.4 in here for A. And C is going to be this slant height, this 42.2 squared. So again, I'm going to use my calculator to help me out here. So I'm going to do 14.4 squared. So 14.4 times 14.4, and I'm going to put the entire decimal that I get, which is 207.36 plus b squared, and now I'm going to do 42.2 times 42.2, and I get 1,780.84. Now it's time to solve to get b by itself. I'm going to subtract so that my b term can be all by itself. Whatever I do to one side, I am going to also do to the other to keep my equation balanced. And when I subtract, I get a difference of 1,573 and 48 hundredths. So my final step, if I want this b squared to become just a b, I need to take the square root. If I take the square root of one side, I have to do that to the other. And when I take the square root of 1,573 and 48 hundredths, it's going to give me an approximate answer. So I would say this is about 39.7 centimeters. So let's back up a second and also change this to approximately equal to, because we didn't get exactly 21.6, we rounded it. So those are your final two questions for 12.3, and you are all set for your Digits 12.3 homework. I know you'll do great.